Right? So we are going to design a spectrum analyzer using a band pass filter, power meter, and a microcontroller with the LCD. Okay. So spectrum means some frequency range is there, F1 to F2, and corresponding power levels are there. Okay. So this should be a tunable band pass filter. Then we can tune this band pass filter to some frequency range. Okay. Some for some band, F1 to some certain value. Let's say that that is delta F1 or something. Then you can measure the power level using this power meter. Then you can store it, this frequency delta F and the power range. Actually, you have to get the maybe the middle point. You can consider the middle point of this frequency. Then you can have some frequency value, and then you can have the power level. Okay. Then again, this band pass filter is tuned to another uh, band, let's say that delta F2, then you can consider the middle frequency F2, okay? Then you can measure the corresponding power level using this power meter, okay? Likewise, you can tune this band pass filter for several bands, okay, within this range F1 to F2, then you can get the corresponding power level, okay? Okay, you can store it here, okay? Then this microcontroller is there. Okay, you have to code, you have to interface this band pass filter and power meter and storage device, maybe RAM or ROM, using the microcontroller. Maybe you can use the internal RAM or ROM for this task. Okay, if it is not enough, you have to interface another external storage device with the microcontroller. Okay, then you have to write the libraries and codes to control this component, okay, and also the LCD, okay. Now you have in the storage, you have the frequency versus power, okay. So this microcontroller, you should code this microcontroller to plot this value in the LCD, okay. So that is very simple. That is the spectrum analyzer, okay. So this technique is mainly used in many spectrum analyzers. Okay, this is one standard method to construct the spectrum analyzer. Okay, so there are other methods also. Okay, so this is one method. Okay, very popular method. Okay, so many optical spectrum analyzers are working on in these principles. Okay, okay. So RF frequency, RF spectrum analyzers are also use this technique. Okay, okay, okay. So I think that is what we need to discuss, no? Okay. So we have discussed from here to here. Okay, from here to here. Okay. So the measurement, oscilloscope, time domain, spectrum analyzer, frequency domain. So in oscilloscope, you can measure period, frequency, voltage like this, okay? And the advanced oscilloscopes are there. You can measure you can get the harmonic also using the advanced oscilloscope, okay? We call them multi-signal oscilloscope, okay? And sampling oscilloscopes are also there. Those are advanced oscilloscope. Maybe using this oscilloscope, you can measure bit error rate, SNR also, okay? But the basic, the fundamental measurements we take using the oscilloscope is some time domain measurement like frequency, period, and the corresponding voltages, okay, or power, okay. Using the spectrum analyzer, we can get frequency domain measurement, okay, the harmonics, the corresponding power levels, okay, SNR, signal to noise ratio, those kind of measurement we can get using the spectrum analysis, okay. So here you are asked to draw this signal, okay. So this is a sinusoidal signal. This is the frequency. You can calculate the one cycle time, okay. Then you can draw this signal. Then you have to add some DC value. Then this signal will be shifted, okay. You can write it, okay. There is no change in the free period or the cycle, okay. The same period is there, okay. So you can get it, okay. Okay. So this kind of signal is a composite signal, okay? So if you consider this one, okay, here there is no frequency component, zero frequency component. You have F1, F2, F3 frequency component. F3 is the lowest one, then F2, then F1, okay? So F1 power is 10 square divided by 2, that is 50, okay? Okay. And here also F3 also 50, this one 20 square divided by 2, that is 200 watt, okay? So the spectrum will look like this, okay? And there are some factors you have to consider when you get the measurement using the measuring instrument, anyone, okay? First, you should adhere the safety precautions. Then you have to adhere the range. Those are very important, okay? And RF spectrum analyzer, there are some specific tasks, okay? So we will learn them in our lab session, okay? After the exam, okay? But I think you already know some important factors you have to consider when you are doing. Okay, when you are doing four questions, okay? There are four questions, okay? So when you are doing, when you are getting the measurement, okay? So these things we have already discussed, okay? And this is our methodology to create a spectrum analyzer using tunable band fast filter, power meter, and the storage device. Okay. So all these things are interface with the microcontroller together with the LCD. Then this setup you can use as a spectrum analyzer. Okay. Okay. So shall we stop now? Okay. The four question will become to the exam. Okay. And the exam will be 2 hours, no? Okay, so you have 30 minutes, okay? So very simple questions are there. Okay. So do this tutorial, then you can answer the questions very well, okay?